Hello. In this lesson, we're going to be talking about functional notation. As a reminder, a function is a relationship between inputs and outputs. What functional notation will do for us is show us both what our input is and our output is at the same time. So we have this thing right here, and it's read as f of x. Now, this is not the same thing as f times x. It's read as f of x. F is representative of a function, okay? It's basically a letter meant to represent an entire function. And in this function, we have inputs of x. So in some examples, I've changed the letter. We're now looking at the function called g. So g of x is equal to 6x minus 7. Our inputs of x give us outputs of whatever 6x minus 7 is. In my first example, we're finding g of 0. So what this tells me is that we are going to input 0 for x and determine what the output is. So g of 0 means each of my x's become the number 0. So we're looking at 6 times 0 and then minus 7. Well, 6 times 0 is 0. Still minus 7 gets me negative 7. So an input of 0 gives me an output of negative 7. For g of 4, same thing. We're inputting the number 4 for x. So we have 6 times 4 minus 7. 6 times 4 is 24, still minus 7, and 24 minus 7 is 17. So an input of 4 has an output of 17. In number 3, g of a, again, all of our x's just get replaced with the letter a. So we're doing 6 times a, and then minus 7. Now, nothing we can really do here. 6 times a is not a number we can evaluate, and we would need to do any multiplication before we were able to subtract here, according to order of operations, so it will just stay as 6a minus 7. In number 4, we're putting in place of x, 4x minus 1. So we're doing 6 times 4x minus 1 minus 7. Well, this we can do something with. If you remember, we can distribute that 6 through to both things to simplify. So we have 24x minus 6 and then minus 7. And so to simplify 24x, negative 6 minus 7 is a negative 13. 24x minus 13. And in the last one, it's kind of weird. We're doing g of wombat. So in place of x, we're just going to put the word wombat. And I know it's weird, but it's just to illustrate the fact that it doesn't matter what you're putting in. All that, whatever it is there, just goes in place of x. And then you do with it what you can. Sometimes you can do something with it. Other times it just has to stay as it is. Okay, so that's functional notation. For now, we're done.